Hello colleagues, let's discuss today the basics of indoor positioning system for industrial applications. We will not talk about museums, sports, or shopping malls or airports. That's a great area, but it's not the focus for this. We are talking about something industrial like warehouses, factories, mines, construction sites, oil, gas refineries, railways, metro, underground, and let's discuss about the benefits of some basics of the technology and its key capabilities. What the system is designed for, and in general, why their indoor positioning systems are required at all. Now, there are three major ones: safety, productivity, and automation. Safety, it's first of all safety for people. Accidents prevention, accidents post-analysis, prevention of broken equipment or vehicles or similar. Then about productivity. It's about lost assets, lost equipment. We know that my cart is somewhere inside this building, but we don't know where. We know that the pallet is somewhere, but we don't know where. And we lose time trying to find it. We underutilize assets. Their forklift is driving, but is it driving optimally? What's the time the forklift is driving compared to what's the time the forklift is basically staying still and waiting? So what's the asset utilization ratio? And of course about automation, all kind of automation. Robots, drones, AGVs, to drive them. In order to them to be able to drive, they need to know the location in one way or another. There could be some other systems used, but in one way or another, indoor positioning system is required for autonomous drones, for autonomous robots, for autonomous guided vehicles. So what's the problem with GPS, with indoor positioning system? The problem, the major one, is there's no GPS. And there's no GPS because when you're indoor, the radio signal from GPS satellites simply cannot penetrate through the walls, through the ceiling. So there's no GPS inside. And even if GPS is available inside, the accuracy of GPS is not sufficient for indoor positioning system because typical GPS gives a few meters accuracy. When you have industrial applications and general indoor applications, you typically need centimeter level accuracy, not meter level accuracy. And in terms of GPS, it's rather not a meter, but 10 meter accuracy. There could be some other options, for example, installing cameras, but it's more expensive and it typically doesn't work well. For example, who is this person? When the people are in uniform and the lighting is poor, it's very difficult to distinguish between one person and another person. It's even difficult to distinguish, is it a person or machinery with the same color or something. So it's very difficult to implement in practice. So this is why people are using indoor positioning system, and they are tracking, and we will discuss a bit more later, the mobile beacons installed on the people, or mobile beacons installed on the machinery, or the forklifts, or the cranes. So these are the mobile beacons. So once again, it must be very clearly understood, we do not track people. We track mobile beacons installed on the people. We do not track forklift, or AGV, or crane. We track a mobile beacon installed on the AGV, crane, or any asset. And that's exactly why it's more complex and it's very simple, because you can track virtually anything if you can install a mobile beacon on this. And this is why we have different types of mobile beacons: small, large, with internal battery, without external battery, protected against water and dust, not protected, with additional Omni microphones, without, with antenna, with embedded antenna, different variants. But again, the key point is that there's a mobile beacon, or sometimes called tag, which is installed on your mobile asset or the person. And we track the mobile beacon. And then by knowing what this mobile beacon is assigned to, it's possible to know also who are we tracking or what are we tracking and what's the location. But then the big question is tracking against what? It's all about localization. So it's all about coordinates. In a GPS system, we track against GPS satellites, which are flying somewhere far, thousands of kilometers away. And in indoor positioning system, you track against something. What is this something? It's called stationary beacons, or sometimes it's called anchors. You install anchors inside your building, and there is only one important requirement. We will talk about this again, but this must be clearly understood. In order for the mobile beacon to be tracked, it must have a direct line of sight between 2 or more stationary beacons within 30 meters for 2D tracking, or 3 or more stationary beacons within 30 meters for 3D tracking. That's it. Then you basically install as many stationary beacons as you need in order to cover as large area as you wish. So this is why there's virtually no capacity limitation in terms of how large area you want to cover. If you need to cover a huge warehouse of 20 or 100,000 square meters, okay, simply more beacons would be required. They are kind of satellites, but instead of GPS satellites, there are these fixed satellites installed somewhere on the wall or ceiling. Why? Because it's basically the best place in order to provide the least abstraction between the stationary beacon and the mobile beacon. So they are installed somewhere high on the walls or on the ceiling. And then you would need the fewer number of stationary beacons to cover the same area. Typically, they are powered from the electricity, from the fixed power supply. And in this case, you don't have any worries about the batteries. But sometimes it's very difficult to provide the electricity because it's simply not there. In this case, yes, a large battery is installed next to the beacon and it's supplied. And it can provide the supply for a year or even more. But yes, after 1 year, you have to take the battery off, charge it for whatever hours, 24 hours, and then install it back. During this time, the beacon will be supplied from the internal battery, which is there, but it lasts for days rather than weeks or months. Then, of course, the big question is, how do I get the data? Because when the system is installed, that's great that we have positioning, but how do I get, where is this positioning? What's the data? And the data can be obtained from 2 different sources. One is the mobile beacon, and another one is the modem. The modem, sometimes called router, sometimes called controller, is basically a central controller or device which is controlling the system, and it allows you to extract the location data about the mobile beacons. The controller or the modem is talking to each beacon, stationary and mobile, over radio in license-free band, and then it streams out the location data either through USB, basically the same USB as you use in your phones, or through these pins. Because sometimes it's easier to connect using USB, sometimes it's easier to connect using pins. Absolutely the same story with the beacon. But the mobile beacon is great because, for example, if you don't track a person or a forklift, but you have an autonomous robot or drone, then the robot on site where the robot is at the moment, needs to know location precisely. Not from the modem and then send back data somehow. It's possible, but it's kind of too long way. But it will be able to obtain the data right from the mobile beacon. Again, using either USB or the pins, depending on the robot. The same with the drone. So it's very, very easy to get the data. Data is an open protocol, open format. So it means that you can easily get this data and combine this data with your warehouse management system or with your graphical user interface, or send it anywhere. For example, the modem can be a different form as well, as we mentioned earlier. So the beacons are different forms, but the modem can be also a different one. For example, super modem, it contains their Wi-Fi as well. So it's possible to get the data, sent over Wi-Fi, then over internet to anywhere in the world. So you have a warehouse in India, and then your boss is sitting in Germany, or vice versa, and you can send the data directly to the boss address, IP address, and to show nicely what's going on in your warehouse, where the assets are, how many movements the forklifts done, etc. It's very, very convenient in this case. Basics about the technology. All precise indoor positioning systems are using time of flight, but different time of flight. In our case, we are using time of flight of ultrasound. And this is why we are the most precise commercially available system worldwide. Ultra-wideband is also a great technology, but ultra-wideband is using time of flight of ultra-wideband electromagnetic pulses. The same pulses as your radio or your Wi-Fi or even light. It's also electromagnetic pulses, but different frequencies. So ultra-wideband is using time-of-flight technology as well. And LiDARs, for example, or GPS, they are also using time-of-flight. By precisely measuring time of flight and by precisely knowing the speed, propagation speed, in our case of ultrasound, in case of ultra-wideband or GPS, propagation speed of electromagnetic waves, is possible to calculate the distance. As soon as the distance is calculated, then it's possible, by knowing the location of the stationary beacons, to calculate the position of the mobile beacon. That's it. So basically you have one stationary beacon and another stationary beacon. Then you calculate the time of flight of ultrasound from this beacon and time of flight from this beacon. And intersection point will be position of your mobile beacon. That's it. Of course, there are technology behind this complex, to filter, etc. But again, the presentation about the basics and how to use them. So time of flight is underlying technology. Synchronization, we are not using the atomic clocks. We are using something like in this Thunder. So there is a radio pulse, which is synchronizing station beacons, mobile beacons, and the modem. All of them know the time very precisely. And as soon as the time is synchronized, then they start calculating the time of flight of ultrasound. So that's in short. There are alternative systems which are not using time of flight, but they're using RSSI, radio signal strength indicator, or radio signal strength. For example, Bluetooth, BLE, or Wi-Fi, or LoRa. So they're using strength of the radio signal, but strength fluctuates indoor significantly. So this is why those systems are inherently imprecise, because it's very, very difficult to make them not so much fluctuating when you're inside. There's a lot of reflections, and signal strength change dramatically, even nothing is happening. So this is why they're imprecise meters. But time of flight provides you, in terms of ultra-wideband, 10 to 30 centimeters, And in terms of our technology, which is ultrasound plus radio, it's centimeter level, so plus minus 2 centimeters, about 10 times better than ultrawideband. Then the most important requirement for you as managers and ultimate users to remember: line of sight. If you place the beacons and you want to track somewhere behind the corner or somewhere behind the pallets, no, it will not work. It will simply not work. So, and the whole art and a bit science and a lot of technology is to place their beacons, stationary beacons, so that with the minimum number of beacons, it's possible to cover the largest area. Remember, there is only one requirement. We slightly touched it. In order to have 2D tracking, the mobile beacon on the person must see 2 or more stationary beacons within 30 meters. If it doesn't see, then you need to place another beacon, stationary beacon. Okay, in this case, it will see and their position of the person will be determined. If there's a forklift, for example, this forklift cannot be tracked by this station beacon. Then you need to place another beacon and another beacon. These 2 beacons will see the forklift, which is, for example, here, and then the position of the forklift will be determined. And the system will know the location of the person and of their forklift, and the person will be warned, okay, there's a forklift behind the corner, and the forklift driver will be warned that, okay, there's a person, be careful. So that's the fundamental one, line of sight. Line of sight is a must. All other options without line of sight, etc., in some theoretical cases, it's possible, but again, for you, remember the basics, line of sight is a must. It is a must. If you need to have a precise indoor position, it's just a must. Design the system with line of sight in mind. Then basics about the capabilities. Again, very quickly. Accuracy. Accuracy is probably the most important characteristic of indoor positioning system, particularly indoor. So our system is providing plus minus 2 centimeters. Ultra-wideband, which is a great technology, gives around 10 times to that. So 10 to 30 centimeters. BLE, which is not so much designed for positioning, but quite often is used, still we do not recommend it to use for industrial applications. It gives around 100 times worse accuracy than our system, which is around 2 to 5 meters. So kind of room level. Is it possible to track 1D? Yes, it's possible. For example, long tunnel, or a corridor, or just the distance in the elevator. Yes, it's possible. 2D, very typical to track people, forklifts, all kind of, assets in 2D, X, Y. 3D, absolutely yes. But in this case, the mobile beacon must see 3 or more station beacons at the same time within 30 meters. So, for example, for drones or pallets placed in their warehouse or many other 3D applications. Is it possible to track vehicles? Certainly. You place the mobile beacon on the vehicle, for example, cart, forklift, or a car, and you track the position. Track people, certainly. And there are many options to track. So we have shown the jacket or vest. It's possible to do helmet, badge, watch, even belt, depending on particular application. Tracking crans, absolutely. Again, we do not track a hook of the crane. We do track a mobile beacon placed on the hook of the crane. Is it possible to measure not only the location of the hook in X, Y, Z, but also the swing? Sure. Do we provide their accelerometer data or gyroscope data? Of course. Is it possible to calculate not only their location, but also the heading, the direction? Yes. Typically, it's done by installing 2 mobile beacons on the vehicle or the crane, sometimes even the person. Is it possible to use it for autonomous robots? Yes, it's one of the primary applications. For autonomous drones, yes. Effectively, drones and robots is the same thing, but robots are typically in 2D and drones are in 3D. Even boats. What's the difference? Not much difference. Simply for boats, it's typically ingress protected against water and dust. What's the maximum covered area? Effectively, there's no limit. It's like a cellular network. You just install additional stationary beacons and you can cover as large area as you wish. So typically 20,000, 100,000 square meters, not a problem. Warehouse with a lot of shelves. If it's just open area, it could be even more. Quantity of tracked assets. Today, out of the box, 150 units. It could be people, it could be robots, it could be forklifts, it could be robots, people, forklifts, drones at the same time. Yes. Is it possible to expand? Yes, it's possible to expand thousands of units. Again, the same story. So simply in this case, you will have to install not only additional beacons, but also additional modems for high capacity. What's the maximum distance between the beacons? I'll recommend it in typical applications up to 30 meters. So it's basically a density of your network of stationary beacons. But in some special cases, like 1D and tunnels, and using horns, which are providing additional gain for ultrasound, it's possible up to 150 meters, which helps in long tunnels. The system works indoor as well as outdoor, and there is no difference between indoor and outdoor, except for that outdoor beacons are typically more ingress protected, as we discussed, against water and dust. And as a bonus, again, since we already know the basics, and engineers are trying to, puzzle you with all the warnings, so basic cheat sheet about this. GPS is Global Positioning System. It's basically what you use when you want to localize your mobile phone or your car GPS positioning system. GPS doesn't work indoor, and that's the starting point for any indoor positioning system. There are so-called GNSS, Global Navigation Satellite System. GPS is one of the GNSS systems, but not the only one. There's GLONASS, made by Russia. There's Galileo, made by the EU. There is a Japanese version and Chinese versions as well. So all of them are versions of Global Navigation Satellite System, and GPS is the most known of them, made by the US. Real-time locating system, indoor positioning system, indoor navigation system, and indoor GPS is virtually the same thing. It's just different terms for effectively the same. For example, a real-time locating system, it doesn't say anything about is it indoor or outdoor. But typically, people use real-time locating system, meaning indoor positioning system. Sometimes it's not only positioning, but also navigation, for example, for robots. But again, remember that RTLS, IPS, INS, and indoor GPS is virtually the same thing. Mobile beacon and tag, again, the same, depending on what technology you're using. We are using the terms mobile beacon and stationary beacons. And in ultra-wideband, people typically use tag and anchors. The modem, router, or controller is also the same thing. It's a kind of central device which is controlling your system and which allows to get the location data out of the system. Again, ultrasound, ultrasonic, interchangeable terms, the same. The important parameter for any precise indoor positioning system or any indoor positioning system is location update rate. So it's basically how often you can get the location data about your mobile asset or the person. It's real time, of course, but what is real time? In some cases, for example, people tracking, it's typically 1 hertz, so 1 update per second. 1 to 4 hertz, so 4 updates per second. It's sufficient for people tracking, typically. For vehicles, it's about the same, 1 to 8 hertz, so 1 to 8 updates per second. It's very similar to update rate of GPS, for example. But in some other applications, like drones, or in some case virtual reality, it's insufficient. So you need a much higher update rate, like 20, 30, 100 hertz, so 100 times per second the update rate. But in terms of semi-static or static assets like pallets, it could be 1 per minute, 1 per 5 minutes. Why is it important? Because it affects many parameters, most of all the battery lifetime. If your mobile beacon has a battery powered, not electricity connected, then the battery lifetime does matter. So, and the fewer update rates per second you have, the longer battery lifetime will be. Time of flight we already discussed, so TOF, time of flight. And time of flight of ultrasound, or time of flight of radio, or time of flight of light. The same in terms of technology, but slightly different physics, underlying physics. Trilateration is the method to calculate position based on the distances measured in time of flight. So if you have 3 distances, then it's trilateration, and you can calculate x, y, z. If you have only 2 distances, then it's bilateration. So you can calculate 2D or xy. But in general, it's multilateration. UWB, ultra-wideband, it's a great positioning technology which is using the radio and time of flight of radio pulses, short radio pulses, and this is why they're ultra-wideband. BLE is a Bluetooth Low Energy, is a telecommunication protocol which can be used in some cases for positioning. But as we discussed, it is using not time of flight, but it is using radio signal strength in order to estimate the distance. And that estimation is highly imprecise. So this is why with ultra-wideband you can get 10 to 30 centimeters. With ultrasound you can get around 2 centimeters. And with BLE you can get 2 to 5 meters accuracy of position. RFID, some people consider RFID as an indoor positioning system, but in fact it's pretty rudimentary indoor positioning system, if you can call it, because it's radio frequency identification. Basically, it means that it's gate type system. You don't know the location unless you are next to the gate, door or relay gate. In this case, yes, you know that the person passed this location point at some time, but where it was before or where it will be, so nobody knows. So this is why RFID is not a real-time locating system, because you don't know current position. You know the position at some point of time when the person with this RFID tag passed this RFID reader. LoRa. It stands for long range. Again, it's one of the telecommunication protocols which is normally used for data transmission, like BLE. But some people are using it for positioning. The same story as BLE, yes, can be used, but no. It gives pretty inaccurate positioning and is not recommended for indoor positioning for industrial applications. LiDAR, light detection and ranging. It's using time of flight, but in this case, time of flight of laser. And it's great for obstacle detection. But yes, particularly for robots or AGVs, it can be used also for positioning. Thank you very much, colleagues. If you have any questions, of course, come to our website, check and send us a message to info@marvelmind.com. Thank you.